The last time we just created a connecting rod, we put a hole in the center, which means that we already have some theory about the fact that we can reduce the weight of the connecting rod and make it lighter and reduce the theory. This time we're going to create a much simpler connecting rod. We want to demonstrate an here. These episodes get bigger skills. As we normally begin our journey with creating sketches, this time we are not going to start. Instead, we are going to go to the modify section of the drop-down menus, and we are going to go down in that, and we're going to look at change parameters. When we get to change parameters, we are given something that gives us important information that we can change or we can add, like user parameters, the parameters, favorites, and so on. But here we're going to just focus this first example on user parameters. And if you look here, it says plus user parameter. You can add a user parameter that was not there before. Right now, we have a drawing that is nothing. There's no user parameter here. So if we click this one, so it asks you to enter the parameter name. So we begin by naming the name of Big Pen. Big Pen is our first user parameter. Later, it's actually the to be a single word, so let us graph. If we're happy with that, we drop in 50 and it is called Big Pen. So it is recorded there and user parameter Big Pen, the expression. It's us to start. Let us now take our another one. So we talk with us. As a pen in the distant end. And for the expressions of the name is for the expression here should be maybe Big Pen. So that is it. So that's the expression. Then another one we want to put there is the length one. So add user parameter and then let us say L1. L1, let us say L1 is, for instance, we can put L1 as Big Pen divided Big Pen multiplied by times 3.2. Big Pen multiplied by 3.2. Let's see, multiplied by 3.4. Let's see, 3.5. Okay, so that's the length. Center to center. So we have that as the length of center to center. Then the next thing we want to do is add the thickness. T1 is the thickness, and what's thickness now? We just say 15. 15, that is the body. Thickness, and then we want to add further. I think that's enough. Let us click cancel that, and let us just start with this. Let us not make it complicated to begin with. So with those things set up, we are now in a position to do our sketching. So we're going to do a very simple sketch this time. So we create a sketch, And you know, I like to start my sketches on the ZY plane or YZ plane. And what I want to do, I like to pan down, take the pan handle, push it down drag it down with your mouse button, and then we can start, make it a little bit finer, and then take a center circle here, center circle, and the first thing here is that it is the big pin that is the radius of this circle. So if we're happy with that, so that is the diameter rather than radius. Sorry, sometimes I call diameters radius. So most of the time it is the diameter of the circle you specify. Okay, so that is the first thing. The next thing I want is to repeat that command by using my marking menu, and I can say that the second circle has a diameter of big pin, multiplied by 1.2. So big pin multiplied by 1.2. That is that'll look okay. So if I'm happy with that, I say okay. Then the next one is the same, something there again. I start from here and I say it is big pin multiplied by 1.4. Okay, so I have 3 circles there, and then I can do 2 circles up here and say okay, here it is small pin, it is small pin times, let us start with small pin alone. That is then the second one, I want this one, it is equal to small pin times small pin times 1.5. Okay, here what I want to do here is like I want these two ought to be it ought to be coincident. The centers here ought to be coincident. I made the mistake of not making. Okay, so using the coincident constraint, I can put them together. Then I now want to use the vertical and horizontal to make sure that that one is the two are in there. Then the next thing I want to do is to get the distance between the centers. So from here to here, I want it to be L1. Okay, I'm happy with that. That is L1. Now, as before, I want to do a tangent to these two, so I just take a line, long line here, and I'm happy with that. So, and I want this thing to be tangent to my lines there. So I could say I want a tangent constraint between this, and between this and this. So that's a tangent constraint, and I want to do my trimming. So trim this and trim this. So with that trimming done, the next thing I want to do is I want to mirror this line to this side. So I choose mirror, I take this line, and then I choose I want to choose the mirror line. I use the Z axis, so that is the mirror line, and I click OK. So I have mirrored it. But all the time I've been mirroring in the past few videos, I've always used the coordinate axis. Notice that it doesn't have to be. In order to prove that it doesn't have to be, let us forget about the coordinate axis and redo this mirror line. For instance, suppose I cancel the mirroring that I've just done. I could have done a construction line. So do a construction. I will do a construction line by choosing the construction inside the sketch palette on line type, choose construction, and then I start from the center to the center, and that's a construction line, as you can see, because it is in dashes. That line is this is a dash line, that's a construction line. So with that, I can do my mirror again using that construction line. So I can start here. Object to mirror is this, and then the mirror line is this construction line, and that is okay. So it is not absolutely necessary to use the coordinate axis as your mirror line. It's just that when it is there and it is satisfying your conditions, then why should you do more work? Now the next thing we want to do is to do more trimmings. I want to trim this one off here and this one off here. So I'm done with this sketch now. I can now go and do my extrusions. So I can now create an extrude. I create extrude, and I like to start with the body of the element or the component. So the body of the component, usually I like to start from the profile plane, and I want the extrusion to be symmetric for now, and I want to use the total distance to determine that. And if I have here, I defined some thicknesses before. Let us say I'm using T1, which is already a defined user parameter. T1 is what I want there, and I say okay. If I'm happy with that, click OK. So as before, you know that the first extrusion you do removes the sketch you had before. So we have to bring back that sketch, open it up, lighten the sketch so it's there. We want to do another extrusion. The next extrusion we're going to do is on the piston pin side. So we create extrude, and the extrusion will be done here. And then the same thing, symmetric, and we are using the full distance, and I want that extrude to be T1 times T1 now multiplied by the user parameter T1. So I take that user parameter T1, and then let's say multiplied by 1.6. say. So if I'm happy with that, so that is the thickness that we have here now. And then similarly, I want to do another extrude, create extrude on the crankshaft side, and that is it. I want this one to be also symmetric, and I want to use the total distance, and I want it to be a distance of T1 times say 2.3. So if I'm happy with that, it's joining it. So T1 times 2.3. So with that, I have a fully defined connecting rod, which I can now look at. Okay, so this is a connecting rod we have here, and it's a very simple connecting rod, simpler than what we did before. I can take off the sketches so that we can see the connecting rod. This is a simple connecting rod which we can do in a much easier way than we did before. So if we are happy with that, fine. Now suppose I suddenly decide that I want to change the size of my big pin. If I want to change the size of my big pin, let us say I carry this hole first of all, and I remove the something. If I decide to change the size of my big pin, I can say can go back to the modify and look at change parameters. My big pin here was 50. A lot of things are depending on it. So if I make this my big pin 70 instead, and I say okay, immediately everything has changed proportionally. It is thicker. Everything has changed proportionally. You may miss that because everything is proportional. And do not think for a minute that because everything is proportional here, that is how it will always be. I could also go and change the I could also go and change the relationship between the big pin and the small pin, and I can go and modify. I can go and modify the change parameters, and instead of the small pin being a big pin times 2.5, I can go and put a figure there. Maybe I just say that the small pin is only 20, and I say okay. So I can modify that separately. So I can modify anything, and this is a parameterized connecting rod compared to what we did before. Of course, you can modify this further by taking materials off in the center here. All you need to do is to create a sketch here and extrude a cut through this place, and you will get something closer to the connecting rod we started with in the previous example.